Good day, everyone. My name is Teles Banda, a PhD student in the Inclusive Interaction Lab at UCMSed. Today, I'll be presenting WinkSwype, a wing-based, hands-free shape writing method for virtual reality. In this week, I collaborated with Tafazwa Dube, who was a PhD student at the lab, my advisor, Ahmed Aref, and Scott Mackenzie, a professor at York University. Text entry in virtual reality remains challenging as it typically relies on external devices that occupy the hands and are easily misplaced. Traditional keyboards are also difficult to use in virtual reality because users cannot see their hands while fully immersed within the virtual reality environment. Shape writing with gaze offers a promising solution. However, framing the gestures may require the use of dwell, which is slower, or external devices which are inconvenient for people with motor disabilities. WinkSwype is a novel hands-free gaze typing method that enables users to frame gestures by closing one eye. To enter a word, the user first closes one eye, traces a path over the desired letters using the other eye, reopens the closed eye to stop tracing and to trigger word recognition. The system then automatically enters the most probable word. Then the user can also pick a less probable word from the suggestion bar, delete a word, or enter special characters, digits, or symbols by dwelling over the corresponding keys for 1000 milliseconds. Since typical eye trackers are not optimized for single eye gaze, we developed a custom single eye calibration system. In an iterative design process for this, we developed an interface that arranged 180 red circular targets in 9 zones across the display to enhance spatial accuracy. We then compared ratio-based, linear regression-based, and Gaussian-based calibration functions, where the latter model outperformed others, achieving a gaze accuracy of 1.1 degrees of visual angle. Therefore, we used it in our final prototype. We also investigated different models for word recognition, specifically string matching approach, exploiting dynamic time wrapping, a pattern matching approach that matches the gesture patterns with gesture templates, and a custom hybrid rank-based model that combines the two and ranks words based on the total prediction score. We used the hybrid rank-based model on the final prototype as it yielded over 100% higher accuracy rate compared to others. We then compared WinkSwype with 2 baselines in a within subjects design with 18 participants. The first used a controller with raycasting where users hold the trigger while drawing the gestures. The second used a gaze trigger approach where users draw gestures with gaze and press holding the trigger. All 3 methods use the same gesture recognition pipeline. In the study, we used an HTC Vive Pro Eye headset with integrated eye tracking. In the study, participants transcribed 5 short phrases in a block with a total of 3 blocks per condition, which were counterbalanced to reduce order effect. The study recorded entry speed and accuracy. Also, after the study, participants completed 3 questionnaires to rate their perceived workload, usability, and visual fatigue. Results revealed raycasting to be the fastest, followed by gaze trigger and WinkSwype. It is promising that participants were able to retain about 58% of their raycasting and 68% of their gaze trigger entry speed with WinkSwype, given that it is a fully hands-free method requiring no additional physical actions, making it potentially suitable for motor impaired users. Results also showed that all methods improved with practice. All 3 methods yielded similarly low error rate of about 2%. In the final block, WinkSwype comparable error rate to guess trigger provides an indirect validation for single eye calibration model proposed in this work. No significant differences were found in the perceived workload across the methods. In fact, participants described WinkSwype as more engaging and less physically fatiguing than raycasting, which involved prolonged arm use. While most usability matrices were comparable, participants showed a clear preference for gaze trigger, likely because it combines familiar controller input with gaze-based pointing. Interestingly, no significant differences were observed in visual fatigue across the methods, but WinkSwype was associated with slightly higher visual fatigue ratings, likely due to prolonged single eye use. The results suggest that WinkSwype has potential as a hands-free text entry alternative for virtual reality environments. In future, we will improve the calibration and gesture recognition process and evaluate WinkSwype with motor impaired participants. Thank you.